Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to solve radical equations. In this tutorial, we're going to be focusing on the type of radicals where we have a radical equal to a binomial. The instruction for the examples are as follows. We are to solve the given radical equation algebraically, and then check our answer, and then graphically solve the situation using a calculator. Okay, so let's start with the first part, which is to solve algebraically. Algebraic solution. That's how we'll title it. Now, when you're solving radical equations algebraically, the number one goal is to eliminate the radicals so you can solve the resulting quadratic or linear equation using the appropriate algebraic steps. Now, to get the radical component isolated here in 1 equals negative n plus the square root of 6n plus 6, we have to first add n to both sides of our equation. Now that results in, just put a line here, we have n plus 1 equals, these two n's cancel out, the square root of 6n plus 6. Now that we have the radical isolated, we're going to go ahead and square both sides because the inverse of square root is square. And when we square the right side, the square roots cancel out. On the left side, we are going to have n plus 1 times n plus 1. Please do not distribute the square across the sum of terms. That's not appropriate. We have to multiply this binomial by itself. On the right side, the square and the square roots cancel out, so we're left with 6n plus 6. Now let's expand this binomial by distribution. We're going to do first, outer, inner, and last. You can multiply with a box if you are so inclined. N times n is n squared plus, that's the first, outer is n, inner is n, last is 1. Okay, that's equal to 6n plus 6. Now, what we have here, let's go ahead and simplify a little bit further. We have n squared plus 2n plus 1 equals 6n plus 6. This is a quadratic equation. Now, how do we go about solving quadratic equations? We put them in standard form. Set it equal to 0 with the terms in descending order of degree. All right, so we need to set it equal to 0, which means 6n plus 6 has to be moved to the left side of the equation. So we subtract 6n from both sides, and then subtract 6 from both sides. And let's see what that gives us. We have n squared minus 4n minus 5 equals 0. So what do we have now? This is a quadratic equation in standard form, so we can go ahead and solve either by factoring or using the quadratic formula. In this problem, we have a is 1, b is negative 4, and c is negative 5. We're going to use the AC method and hope it works. So AC is 1 times negative 5, which is negative 5, and b is negative 4. Okay, AC and b. Now, are there any two numbers that multiply to give you negative 5 and now to give you negative 4? Absolutely. Negative 5 times 1 is negative 5, and negative 5 plus 1 is negative 4. So since a is equal to 1 here, that means we do not have to factor by grouping. We can jump directly to the factor state, which is n, extract this number, minus 5 times n, extract the other number, plus 1 equals 0. And we're going to use the zero product property to finish this off. So we're going to set each factor equal to 0. So we have n minus 5 equals 0, and n plus 1 equals 0. All right, the first one, you actually add 5 to both sides. First possible solution is n equals 5. And then in the second equation, you subtract 1 from both sides. The second possible solution is n equals -1. Okay, so whenever you're solving radical equations, because there are constraints on the domain and we're squaring both sides, we might have extraneous solutions, solutions that do not satisfy the original equation. So how do we know if these two answers are correct or if one or both are extraneous? That's where the check comes in. Okay, so let's go ahead and carry out our algebraic verification. So we're going to do our check. We're checking this equation right here. 1 equals -n plus the square root of 6n plus 6. The first answer we got was n equals 5. So what we're going to do is substitute 5 into the n's in this equation. So the question is 1 equals -5 plus the square root of 6 times 5 plus 6. Is this a true or false statement? The left side has already been completely simplified, so we'll just use the order of operations to simplify the right side. All right, so we have -5 plus the square root of 6 times 5 is 30 plus 6. And then we have 1. Is it equal to -5 plus the square root of 36? Is 1 equal to -5 plus the square root of 36 is 6? Is 1 equal to 1? Absolutely. So that shows that n equals 5 is in fact a solution. Now, how about the second solution, n equals -1? Let's determine if it's a solution or if it's extraneous. All right, so the question is 1 equals -1? Use parentheses here, especially when you're dealing with negative numbers to avoid making sign errors. Square root of 6 times -1 plus 6. Is this statement true or false? Let's go ahead and simplify the right side using the order of operations. So we have, is 1 equal to -1 times negative is +1 plus the square root of 6 times -1 is -6 plus 6. Is 1 equal to 1 plus -6 plus 6 is 0? Is 1 equal to 1? Because the square root of 0 is simply 0. The answer is yes, so our answer is correct. Okay, so since both of them check out, our solutions are n equals 5 and n equals -6. So both of them are our solutions. Now, according to the instructions, we are to solve the same problem using our graphing calculator function. Okay, so what we're going to do is we're going to graph this equation in the following format. We're going to set the left side of the equation, that's going to be our y1, and then the right side of the equation is going to be our y2. Okay, now the independent variable in the calculator is x, so instead of n, we're going to use x. Okay, so let's title it Graphical Solution. Hopefully we get the same answer as we did with our algebraic approach. So for the graphical solution, first thing we're going to do is we're going to graph two functions. First one, y1, is the left side of the equation, which is 1. And then for y2, we're going to be graphing negative instead of n is going to be x plus the square root of 6x plus 6, because the only independent variable that our calculator works with for graphing is n. Okay, so that's how we're going to input the functions. Now, what we're going to do next is we're going to find the intersection after graphing with our calculators. Okay, so let's go ahead and graph it first. So y1 is 1, and then y2 is negative. Please do not use the minus, use the negative button, okay? Negative x plus the square root of 6x plus 6, enter. Let's zoom standard. There goes the constant function, y equals 1, and then the radical function. Okay, so we can clearly see an intersection here. Let's go ahead and determine what that is. So second function, calculate the intersection. First curve is y equals 1, yes. Second curve is the radical one. Enter. Guess. Let's scroll close to the point of intersection. Okay, or you can just type in, since we already know what the answer is, we can just type in 5 and be precise, but I'm just going to scroll somewhere close by there. Press enter, and you see x equals 5 is one of our solutions. Okay, so based on the graph, remember we're just focusing on the x coordinate of the intersection because we're looking for x. Okay, so step number 2 is to find the intersection. Find the intersections. All right, so we have one, x equals 5, but we have two answers when we did this algebraically. We had -1 also, but if you look at the graph, it's not clear that -1 is a point of intersection. The reason is because of the nature of this graphing software. Okay, it's not the resolution of the pixels is not sufficient to capture that point of intersection. So even though we don't see it, let me zoom in a little bit. Let's use a zoom box. Even though we don't see it, it doesn't mean that it's not there. Okay, so I'm going to zoom in. Even though I zoom in, you still want to see that point of intersection. But there is a way where we can verify for certainty that that is actually a point of intersection. Okay, we'll go over that in a second. Let's just zoom in. So I'm zooming in my window so I can focus right in on this area right here. There goes the horizontal function, and there goes the other one. It's kind of getting closer. So to know for a certainty if there is an intersection or not, we're going to use the calculate function again. So calculate the intersection, first curve, enter, second curve, enter, guess. Now I know that -1 is an answer, so I can just type in -1 as the point to guess where the intersection is. If there is no intersection, it will tell me that there is no sign change. It will give an error message. But if there is an intersection, it will tell it to me. Okay, so press enter. Bam, there is an answer. X equals -1. That is a valid point of intersection. Okay, so even if it looks as though there isn't a point of intersection, you always want to verify using the calculate function of your calculator. So there goes our two answers for this problem. All right, let's take a look at the next problem. The same instructions, we were to solve the given radical equation and check it algebraically, then solve the same equation graphically with our graphing calculator. Okay, so method 1 is the algebraic method. So let's do that first, algebraic method. Okay, so just like we did before, the goal again is to get the radical term. We want to eliminate that radical symbol right there so that we can solve the resulting equations. So the strategy for this type of problem is to isolate the radical term and eliminate that radical by squaring. To accomplish that, we'll add n to both sides of our equation. when we do that, we're going to have, let's see what we have. We're going to have n minus 11 equals the square root of 71 minus 7n. Okay, now to eliminate the square roots, we're going to square both sides of the equation, since the inverse of square root is square. On the left side, we have n minus 11 times n minus 11. That's what squaring of a quantity is. And then on the right side, the square root and the squares cancel out. So we have 71 minus 7n. All right, let's go ahead and simplify the left side completely. We can follow that out. First, outer, inner, last. Just distribute, or you can use the box method, whichever method makes you happy. So you have n squared minus 11n. First, outer and inner minus 11n, and then last is plus 121. Okay, that equals 71 minus 7n. All right, so let's simplify further. We have n squared minus 11 is minus 22. So n squared minus 22n plus 121 is equal to 71 minus 7n. All right, it's been simplified, the left side that is. Now, what do we have here? We have a quadratic equation. As we did in problem number 3, if you want to solve a quadratic equation, you have to put it in standard form first, okay? Let's go ahead and do that. Set it equal to 0. So you subtract 71 from both sides and add 7n to both sides. Okay, we have to make sure that it's in descending order of degrees, the terms. So we have n squared minus 15n plus 50 equals 0. All right, so let's go ahead and solve this. Let's try the x game first. AC goes on top, B goes on the bottom. AC and then B. And this problem, A is 1, B is negative 15, and C is 50. Okay, so AC, let's see, AC is 50, and then B is negative 15. What two numbers multiply to give you 50 and add to give you negative 15? How about negative 5 and negative 10? That works perfectly. So since A is 1, we can jump right to the factored state. N minus 5 times n minus 10 equals 0. Okay, now let's proceed to set each factor to 0 using the zero product property. All right, and then to finish this off, you add 5 to both sides. We have n equals 5. And then right here, you add 10 to both sides. You have n equals 10. Okay? So are these two answers valid, or is one or both extraneous? So to determine if these are actually answers or not, we have to do our check. Okay? So let's go ahead and carry out our algebraic check. All right, so we're plugging it into the equation. Negative 11 equals negative n plus root 71 minus 7n. All right, so let's check the first one. First answer we got was n equals 5, was it? Yes, n equals 5. Okay, so we're going to ask ourselves the question, is negative 11 equals negative 5 plus root 71 minus 7 times 5. Is this statement true? Well, let's find out. Negative 11, is it equal to negative 5 plus the square root of 71 minus 35? And then we have, is negative 11 is it equal to negative 5 plus 71 minus 35 is 36? Is negative 11 equal to negative 5 plus 6? Is negative 11, is it equal to 1? Is that true or false? That is false. So what does that tell us? It tells us that n equals 5 is an extraneous solution. Okay? So n equals 5 is not a solution. It's classified as extraneous. Okay? Now, does that automatically mean that the second one we have is a solution? The answer is no. We have to check it also, okay? Because there's a possibility that both answers are extraneous, okay? So we have n equals 10. Question is negative 11, is it equal to negative 10 plus the square root of 71 minus 7 times 10? We just substituted 10 into the original equation, okay? So is negative 11, let's simplify, is it equal to negative 10 plus the square root of 71 minus 70? Is negative 11, is it equal to negative 10 plus 71 minus 70 is 1? Is negative 11 equal to negative 10 plus square root of 1 is 1? Is negative 11 equal to negative 9? That is false. Okay, so n equals 10 is not a solution also. So what does that tell us? It tells us that the equation has no solutions. Okay, so there are no solutions. This is a possibility. Okay, when solving radical equations, you can either have two radical equations where you have a radical equal to a binomial, like the ones we're doing in this tutorial. You can either have one solution, two solutions, or zero solutions. All right, so let's go ahead and see what the graphical result is going to look like. All right, we know that there are no solutions, hopefully. Let's see if our calculator agrees with us. All right, so graphical method. For the graphical method, we will follow the same procedure as we did in number 3. Just put in y1 equal the left side of the equation. Remember, we're graphing as a function of x. And y2 is going to be the right side, negative x plus the square root of 71 minus 7x. And then we're going to find the intersection, okay? All right, let's see what happens here when we have no solutions. So first one is negative 11, enter. And then the second is negative 11 plus, let's clear that, negative x actually plus the square root of 71 minus 7x. Okay? All right, so go ahead and graph the functions. Well, let's zoom standard. So zoom standard. And there goes the radical function. The linear function is not captured in this window because it's at negative 11 and the lowest calibration for the y-axis is negative 10. Okay? So to fix that, we can change the window or we can zoom out. So let's go ahead and zoom out. So zoom out with that as a center. So we can see both functions. Now to really focus in on what's happening here, we can use our zoom box feature, enter, and then let's just put the upper, where's my calculator? Okay, we'll put the upper left corner of our window right here, and then the lower right corner of our window. Let's put it somewhere here so that we can really focus in on what's happening. All right, so enter. There goes the horizontal function, -11, and there goes the radical function. Okay, do they intersect? It doesn't look like they do. So how do we know for a certainty that there is no intersection? Just like we did with the previous problem, you want to use the calculate function of your calculator. So second function calculate, just to know for sure that there are no points of intersection. First curve enter, second curve enter, and then let's go close to that point. We don't have any points to use here because there are no solutions. So go really close by and press enter. Let's see what the calculator tells us. So it's trying to find it. Error, no sign change. So basically, it's telling us that there are no solutions. Okay? So anytime you try and look for a solution to the points of intersection graphically, and you come up with a result like this, that basically tells you that there's no intersection happening there. Okay, so that's a confirmation that our previous answer was in fact correct. Thanks so much for taking the time to watch this presentation. If you found the contents of this tutorial beneficial to you, do give us a thumbs up. We appreciate the positive feedback. If you have any questions about solving radical equations, you can just place your questions in the comment section below, and we'll be glad to assist you as soon as possible. More clips can be found on math.serve.com. You can access our interactive worksheets and examples here. And do not forget to subscribe to our channel for updates to other tutorials such as this. Thanks again for watching, and have a wonderful day.